The first thing to do in order to convert a model to TF Lite is to import the TensorFlow again, and we instantiate the converter, which is a TF Lite converter object. So since our model it's a Keras model, we call this method here from Keras model. So we instantiate the converter and we call the convert method. So we have the TF Lite model. So this model, as explained during the previous class with these slides, this model is basically a flat buffer file, and essentially it describes the operations performed by the model that should be run in the mobile device. Okay, so I'm gonna run this cell here. Okay, so it's done. We have our model converted. It was a little quick. And now it's time to test our TF Lite model. So for this test here, the idea is not to measure the accuracy of the model. Of course, that would be a very interesting and useful test. But for this first hands-on project, our goal here is just to make sure the model doesn't crash when we run it. So let's take a look at this cell here. For this test, we need to have an interpreter, which means we need to have an object that knows how to read the flat buffer that represents the TF Lite model. So first we instantiate this interpreter, which is again provided by TensorFlow. We inform the TF Lite model to the interpreter, and then we create a random input data. So the idea, as I mentioned, is not to evaluate the accuracy of the model. We just want to know if the model can process some arbitrary input data, and we need to check if it doesn't crash, basically. So that's what we do here. So first, we need to get the shape of the input the model can receive. So in order to collect that information, we call this method here get input details provided by the interpreter. And with those details, we select the input shape. So with that information, we use NumPy, that a famous library in Python. We use NumPy to create a matrix with this input shape. This matrix has random values that are float 32. We create the matrix, and then we convert the matrix to a tensor using this method by TensorFlow, convert to tensor. So now we have this random input data, which simulates an image, a random image we provide to the model. So now it's time to perform the inference. So it's very simple. First, we need to allocate the tensors of the model. So we call this method here allocate tensors by the interpreter. Then we set the input tensor providing the input data. And finally, we call this method invoke. So it basically runs the interpreter. So the interpreter can invoke the model and perform the prediction. Okay, next we need to collect the output of the model. So we get the output details similarly to what we did before with the input details. So we call this method get output details provided by the interpreter. And we get the reference to the only output tensor our model has. So we get the tensor, the output tensor with index 0, because we only have one tensor, one output tensor. And we print here with Python, we print the input shape and the output shape, so we can make sure our model didn't crash and the input and output are correct. So I'm gonna run this cell here, and we can see it was very, very fast. That's good, because we need this to be fast in our mobile application. We can see here the input shape is correct. 1, because we have a batch of just one sample, which is the random input. 1 by 224 by 224 by 3, correct. And the output shape is 1 by 120 because our data set has 120 classes or labels. So that's correct. Okay, so finally we have our model and we just need to export it so we can emit our model in Android. In order to do this, we only need to write a file using Python, so it's a regular code here. We write a binary file, and that's what I'm gonna do here. I'm gonna run this out, and that's it. We have this file, so since we're using Colab, this file should be available here, so here it is. And we can download this file so we can load it again in our Android application. So that's what we're gonna do next.